Let's discuss the question number 4 from test 6. This is from machine design, basically the fatigue part. What is given? A shaft is given where the yield strength of the shaft is twice its endurance limit. Which of the following torque fluctuations represent the most critical according to the Soderberg criteria? Okay, so there are four loadings are given as four options. There is minus t to t, minus t by 2 to t, 0 to t, and t by 2 to t. And what are we supposed to do? We are supposed to find out which is most critical according to the Soderberg criteria. Okay, so what we will do is we'll find out the mean load, mean torque, which is nothing but the T max plus T mean by 2, and average or the variable torque will be T max minus T mean by 2. So T max plus T mean by 2 will be T minus T by 2. It will be 0 for case 1. So let's do case 1 individually. Let's consider. So case 1 minus T to 2 T. So T mean will be, these are the general formulas, T mean and T max. So T mean will be T max minus T mean by 2, it will be 0 here, and T variable will be T minus of minus T by 2, it will be T. Okay, the mean is 0 variable. Now for the loading B, minus T by 2 to T, T mean is max is T minus T by 2 by 2, so this is T by 4, whereas variable torque is T minus of minus T by 2 by 2, and so this is your 3T by 4. So this mean and variable you can always understand. I mean, if you have something like this and you have a loading like this, so this is your mean, which is nothing but your max and your mean. So this mean is max plus mean by 2, and this is your the variable part. Okay, so let's continue. C is 0 to t, so t mean will be your t by 2, and t variable will be t minus 0 by 2, which is again t by 2. Okay, so t will be your t by 2 to t, so t mean for this case comes out to be t minus t by 2 by 2. In fact, t plus so this is t plus t by 2, so it will be 3t by 4, and t variable, let me write the complete thing, so it will be t minus t by 2 by 2, it will be t by 4. Okay, so I have the mean and the variable in all. Okay, so now Soderberg criteria means sigma mean by, so if you take a Soderberg criteria something like this, you have the mean, you have the yield strength as the limiting point where you're plotting mean stress on the x-axis and you're plotting variable stresses on the axis, and endurance limit is the limiting point. So all these points are safe, and the Soderberg criteria is sigma mean by sigma y by basically the equation of this line you're writing, and sigma variable by sigma endurance is equal to 1 by FOS. So now taking this can be written in terms of load also, because area is constant, and sigma y is 2 times sigma e, so sigma mean by 2 endurance limit plus sigma v by endurance limit is equal to 1 by f of s. So what is remaining is sigma mean by 2 plus sigma variable is equal to sigma e by f of s. Okay, so this I can imagine in terms of load also I can substitute, because area assuming it is constant. So now I need to find out for all the three loading this function, because once this function is more, means f of x, so this left hand side t mean by 2 plus t is more, then f of s is less, implies it's critical. So what I'll do is I'll try to first find out the quantity T mean by 2 plus Tv. So let's first find out the quantity T mean by 2 plus Tv in all the 4 cases. So case 1, so for A case this quantity will become, just substituting the value, it will be T, and for the B case this quantity will become T by 4, T by 8 plus Tt by 4, so it will be 7T by 8. For C case this quantity will become T by 4 plus T by 2, it will be 3T by 4, and for D case it will become 3T by 8 plus T by 4 is equal to 5T by 8. So out of all these 4 cases, the maximum is T, so which will basically give FOS less. FOS is less for case A, since Tm by 2 plus T variable is more. Okay, so FOS is less means it is the critical loading and more chance to fail. So the answer is A. Thank you.